Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many possible first to third rankings can be made from a list of 12 students? So the problem here talks about the number of ways can these 12 students be placed on a ranking, specifically from first, second, and third. We'll be using here the concept of permutation because it matches the two conditions for permutation. Condition number one, we have no repetitions here. Definitely, if the student is already identified as the first student, then he or she cannot take the second and third rankings. That's why there's a clear assumption here that there are no repetitions. And the second is that the arrangement of 3 students out of 12 on the first, second, and third are counted differently even if the same student but of different rankings. Say for example, student A is the first, student B is the second, student C is the third. If student A and student B interchanges their positions, then the ranking is considered different from the previous one. So we are going to use here permutation in this formula. You have N, P, R. Okay? N means the number of objects, in this case students. So we'll have here 12 students. And then R talks about the number of placement that we are going to take out from 12. So we're going to have 3 students at a time. So we are going to use this formula for our permutation. You have here n factorial over, we have the result of n minus r, then the factorial of that. Take note that if we talk about n factorial, it's the condensed way of writing a product of integers from 1 to n. So we have here n times n minus 1, the number before it, or the integer before it, times n minus 2 until we reach to 1 here. Definitely, as we try to use this formula, you will have here 12 factorial, which means the product of 12, all integers, 12, 11 until 1, over, you will have here 12 minus 3, and you will have here your factorial. Okay? So you're going to use probably your calculators to solve for this, but definitely if you have your calculator, you can try automatically this. You have your formula 12 taken 3. Once you input this in your calculator, you will get the result. But of course, we have this as our longer process if we are asked to show for solutions. So as mentioned, 12 factorial is just a result of 12 times its next integer, 11 times 10, and we could end up here at 9 factorial. I'm just trying to end at 9 factorial because for 1, we don't have much space. And number 2, I can easily cancel that because the result of our denominator, 12 minus 3, is 9, and you will have here your factorial. Once you have your factorials here, you can just simply cancel them. Of course, if you don't like to express this in factorial notation, you can express this until 1, as well as here until 1, and you'll be canceling all those integers as well. In short, the result or the number of possible first third rankings that can be made from a list of 12 students is the result when we multiply 12 times 11 times 10. This is already with the consideration that we were able to cancel the 9 factorial that can be found in both numerators and denominators. Hence, we have 1,320 possible rankings from first to third on the list of 12 students. So this is how we answer this kind of problem for this situation, because this fits the idea of permutation, which means there are no repetitions and rankings or assignments or arrangements are actually counted differently even with the same objects or students in this case. And that's Count It In. Talking about getting the luck of the draw. For all in, subscribe now.